Okay, so as mentioned before, I'm brought up as a theoretical condensed matter physicist, and since '99 I work on superconducting qubits since my postdoc with Hans Moy. And in that research, I kind of sticked with this hardware platform, and the systems and the questions became bigger and bigger. I mean, in '99, the question was, will anything ever work on a single qubit in the first place? That was absolutely not clear by then. There were problems that the qubit and the detector are next to each other. Can the qubit ever do anything, or does the detector constantly measure? And history has told us it can do something. But the systems went bigger and bigger. I then went to Munich, as you mentioned, did my habilitation as the German second doctorate, then became a professor at IQC at the University of Waterloo. And that was a time when we went from looking at 1 or 2 qubits at larger systems, and we're also getting a bit more quantitative. So in this era, the question was not, can we do a 2-qubit gate, but how can we start pushing fidelities? How can we start making good 2-qubit gates? Which is also where my work on optimal control theory started, which is now a lot of my activity, which, if you want, is the low-end part of the quantum firmware, where you are translating your bare hardware capabilities into the best possible, which means low error rate and fastest possible gates, which is probably an unglamorous part of the software stack, but that is actually one reason to work on it, because there's a lot to be gained. And in this era, we were starting, yes, to look at the few qubit level to make things better, to make things more efficient. And it was still very hardware driven. And since 2011, I'm in Saarbrücken. And our work touched more and more also on the connections to algorithms. How do we implement them best? How do we adapt them best to hardware? I've been involved in several large research projects, and oftentimes, I'm a theorist, but oftentimes I work as the go-to theorist of a experimentally dominated team. I was part of an experimental team led by John Martinez before he went to Google, for example. So this was often theory that was pragmatic, that has an interface to experiment, and at the same time has an interface to more abstract theory. And